Hello and welcome to the Chemistry Academy. In this video we're going to look at ions in the context of the National 5 chemistry course. So ions, the definition of ions is something that people often struggle to put into words, but it's pretty straightforward. Ions are just charged particles. So if you see anything that's got a negative charge or a positive charge on it, you could class it as an ion because it's not a neutral atom anymore. So remember, atoms are neutral because they've got the same number of positive protons and negative electrons, so those charges cancel each other out. But in the case of an ion, what's happened is it's either gained or lost electrons, which means that positive proton and negative electron balance has now been put out and they're not equal anymore. Okay, so things form ions by the gain or loss of electrons. The number of protons in the nucleus doesn't change when it comes to forming ions. So the atomic number is not going to change and the mass number won't change either because electrons don't weigh anything. So the reason that atoms actually react and end up forming ions is because all the atoms are trying to obtain a stable electron arrangement like the noble gases. So you won't find the noble gases forming ions because they already have said stable electron arrangement. What is a stable electron arrangement? A stable electron arrangement is just a full outer shell of electrons. So if you're looking for a stable electron arrangement, just have a look down at the noble gas group and any of their electron arrangement is a stable one. Atoms have to react to form the ions because the electrons that they're either gaining or losing have to go or come from somewhere. So you won't just find an atom forming an ion on its own. There will usually be another atom somewhere that's collided with and there's been a transfer of electrons usually. So if we get on to then how the atoms then form ions and how we work out what the charge of an ion is going to be. So when atoms lose electrons, they become positive ions. Now this is the bit that people get most confused about because we always think losing is a negative thing, and so we always think if it's lost electrons then it must be negative. However, remember, electrons are negative, so if you're losing something negative, you're actually becoming more positive. Okay, so when atoms lose electrons they become positive ions, and it's generally the metal atoms that will lose electrons. Okay, they generally lose electrons because if you look at their electron arrangements, they're closer to a stable electron arrangement by losing. So if we take lithium for example, a lithium atom has the electron arrangement 2,1. The next stable electron arrangements closest to lithium would be just 2, like the electron arrangement of helium, or 2,8, 2,8, the electron arrangement of neon. However, if it was going to go up to 2,8, it would have to find 7 electrons from somewhere. That's quite a lot of electrons to try and find, whereas it could just lose its one outer electron. It just gives one electron away and then that's it. Now it becomes stable, so that's what happens because that involves the least number of electrons being transferred. So the lithium atom will lose one electron and then it ends up with the electron arrangement 2 because it's just lost that outer electron that it had, giving it the electron arrangement 2. Like I said before, because it loses an electron, it then becomes a positive ion with a single positive charge. Okay. If we take the example of magnesium, we're not going to draw out the diagram this time, but magnesium's electron arrangement is 2,8,2. So its possible stable electron arrangements would be 2,8 or 2,8,8. But going to 2,8 involves the transfer of the least number of electrons, so its arrangement is going to end up as 2,8, meaning it will lose 2 electrons. Because it's lost 2 negative electrons, it then ends up with a 2 positive charge. Okay, so for every 1 negative electron that's lost, there's a 1 extra positive charge on the ion. Okay, so that's how you would generally work out in the data booklet. You would look at the electron arrangement for the atom, see how many electrons it needs to lose or gain to get stable, and then depending on that number of electrons, that will then give you what the charge will be. One thing to watch out for though, because I did say that metal atoms will generally lose their electrons, hydrogen, although it is a non-metal element, it is at the top of group 1, and the main reason it's at the top of group 1 is because it has the same number of outer electrons as group 1, because it's only got one outer electron, but also it forms a positive ion like the rest of group 1. So everything in group 1 will form an ion with a single positive charge. So that's another reason that hydrogen is actually placed in that group. So it will lose its one outer electron, and it actually ends up with an electron arrangement of 0. It'll have no electrons left when it's an ion. So a hydrogen ion is essentially what we would call a proton, because it's just the single proton that's left. It's lost its only one electron that it had. If we then have a look at atoms when they gain electrons, so when they're gaining negative electrons, they become negative ions. If you take on more negativity, you'll become more negative. And it's generally the non-metal atoms that will gain electrons. Of course, hydrogen is the exception to that rule. So if we take oxygen as an example here, oxygen's electron arrangement is 2, 6. It's got 2 electrons in the first level, 6 in the second. The stable electron arrangement it could possibly have, it could go down to 2 by losing 6 electrons, or it could go up to 2, 8. That only involves gaining 2 electrons, so that's exactly what happens. So it gains 2 electrons and it becomes 2, 8. Because it's gained 2 negative electrons, its charge ends up as 2 minus. Okay. If we take another example of nitrogen down here, so nitrogen's electron arrangement is 2, 5. The closest electron arrangement, stable electron arrangement to it will be 2, 8, because 2 would involve losing 5 electrons, whereas going up to 8 only involves gaining 3. So it will gain 3 electrons, and therefore it becomes N3 minus, because it's gained 3 negative electrons. Okay, so that's how the ions generally work. One other thing to note is that when atoms lose electrons to form ions, they tend to lose an outer electron shell. So they end up with one less occupied energy level, whereas when the atoms are gaining electrons to form their ions, they end up with the same number of occupied energy levels. So it's just the electrons go into the same layer that was already there. This can be a useful thing to bear in mind when it comes to some multiple choice questions. Some of the multiple choice questions will have an answer that involves something becoming, so the question will involve something becoming a positively charged ion, and it will ask you which thing has changed, and quite often the answer is the number of occupied energy levels, because that's gone down. Just an extra thing here, that based on the group that the element is in, you can quickly work out what charge the ion would have using this pattern. So for group 1, they've always got a positive 1 charge. Group 2 elements always have a 2 positive charge. Group 3 elements always have a 3 positive charge. Group 4 don't tend to form ions, so you don't really get asked about them. Then when we get to group 5, that's when they start to gain electrons to become stable. So group 5 would have a 3 negative charge. Group 6 end up with 2 negative. Group 7 end up with a single negative. I don't know why I put 1 there. And then group 0 don't form ions like we said before, because they've already got their stable electron arrangements. Okay, so this is a good thing to bear in mind as well, just to quickly help you work out any ion charges, especially if you are going on to work out ionic formula, or you're trying to work out the charge on an ion for any reason. Okay, if you're asked to work out the number of electrons in an atom based on the ionic charge, so let's say, I'll squeeze this here. So let's say we've got a fluorine, and it's got a single negative charge because it's in group 7. And we're asked how many protons, electrons, and protons and electrons the fluorine has. We'll not do the neutrons. So fluorine is atomic number 9, which means it's going to have 9 protons. Okay, the number of protons is always the same as the atomic number, so you just look up the atomic number in the data booklet. The number of electrons should be 9 if it's a neutral atom, but it's got this 1 negative charge here, which means it's got 1 extra electron, so it would end up being 10 electrons. Okay, so an atom will be negative, an ion will be negative if it's got more negative electrons than positive protons, and it will be a positive ion if it's got more positive protons than negative electrons. We can do another example here for, let's do sodium. So sodium, in fact, we'll do magnesium. So magnesium, as we said before, is a 2 positive charge. Its atomic number is 12, so that means it's going to have 12 protons. It should have had 12 electrons as an atom, but it's got a 2 positive charge, which means there's 2 being lost, so it has 10 electrons also. Okay, so that's essentially ions and all the different things that you tend to be asked in relation to them. But the key things to remember are that when atoms lose electrons, they become positive ions, and when they gain negative electrons, they become negative ions. And then just remember the pattern here. But the key is that they're always gaining or losing electrons in order to obtain their stable electron arrangements. So it always comes back to that fundamental reason for why they're doing it. So if you remember that fundamental reason, you can always work out what they're going to do, because all they're trying to do is become stable. So if you found this helpful, please give it a like, don't forget to subscribe, and I'll see you again soon.